I'll just cut you off in a really rude and disrespectful manner. But other than that, I will, or if you just keep asking the same question over, or one that makes me feel uncomfortable as a human being. I have prizes for those who start to ask questions, and I'm disqualifying the question from yesterday is, can I have a prize? Right? That question does not work. I know, but it was basically a prize. So I'm disqualifying. That's all the places you can find me. I'm not going to go into Ingress today because we don't have enough time. So the goals for today, thank you, Sophia, for giving the Docker talk right before mine. That makes me not have to talk. Was everybody here at Sophia's Docker talk? Who wasn't? Who? Okay, keep your hands up. Keep your hands up. Keep your hands up. Do you guys all know what Docker is? Kind of. Okay, well, so then I'll do it quickly. Those who can help me, we'll team teach that together. And then most of it's I'm going to try to show demo. Okay. For those of you that are in my workshop, I'm going to demo what we did in 4 hours. So that should give you a sense. So containers again. This is what Sophia talked about. I think this is actually a very similar picture as well. This is what most of you are using now, which is VMs, right? And the problem with a VM, or benefit, depending on what you do, is you are basically booting an entire OS every time you boot up a VM. So you may be just caring about the apps and the bins or libs that come with it, but you're also getting the overhead of the entire OS, right? And the other problem that comes with that is if you need to patch something, you have to patch each individual OS. The other problem that comes with that is how many of you use VMs right now? And how many of you use it for your development work on servers? A bunch of you, right? And how angry are your sysadmins that you keep eating up VMs? Very angry, right? Because every time you ask for a VM, you're like, I need 8 gigs. Of course you do, because what you're doing is special. And you never give that VM back, right? And so they're like 4 devs, and they have to buy a new server, right? And so that with this, when we move to something containers and Docker, what happens is you're all sharing the kernel. You're all sharing the Linux kernel. You're all sharing the base system stuff. All you're bringing are your bins and libraries and your app code. So lots of benefits to this. One, you can say I need 4 gigs of RAM, but you're only going to consume as much RAM as your app is actually consuming. So all of your overestimates about how special your application is actually don't matter to the Docker engine because it's actually only going to consume what it needs. So you can get much more density there. The other problem solved is, how many of you are running 2 different versions of PostGIS in your organization right now? Yeah, and how fun is that to put? Can you put them on the same machine? No. You can? How much fun is it putting on the same machine? Not too bad. For normal human beings, how fun is it trying to install that stuff on your same machine? Right? It's a pain because they'll need different versions of Google. I pronounced it correctly, right? Different versions of Google or different versions of Proj4j. And so with this, everything that app needs, it brings with it. Right? And that is awesome. So you could actually run 2 different postfix servers on the same machine, or you don't have to worry that postfix and PostGIS use different versions of GCC. You bring them all in your container. There's a whole bunch of other things. The only thing I want to say that is important for here is there's 2 important facts about containers that you have to remember. One, how many of you have used AWS, EC2? Everybody? Right? And if you go into a running EC2 instance and you change a configuration file, what happens? And then you shut it down and you bring it back up. What happens? It's not a trick question. I'm sure you tried it when you first got an EC2 instance because you thought it was a VM. You went in, you changed something, or you wrote a file to disk, you shut it down, you brought it back up. What happened to that file? It was gone. EC2 images and Docker containers are immutable. It is a compiled binary. Once you compile it, any change you make to a running container, which is an instantiation of an image, if you shut that image down, it is gone. And I think that is the biggest adjustment most devs need to make when they start working on containers. You can't write things in the container and expect them to be there. There's solutions to that, but remember that. But it is also a compiled binary, and you'll see why that's really important when we do stuff in a little bit. All right, any other questions on containers? No? Okay. It's a whole topic. We could have run a whole workshop just on Docker. So how many of you remember high school biology? Or maybe it was college, unless you lived in Texas. Right? If you lived anywhere not in Texas or Florida or South Carolina, you will probably remember an event in evolution called the Cambrian Explosion. And this is when, for some reason in our history, something happened and there was a huge explosion and big diversity in animals, right? Yeah, it's all animals. So a big explosion of diversity in animals. And what I think you should be aware of is right now we're in a time of container explosion. So Sophia and I are both here talking about containers. They've actually been around for a long time. Does anybody, how many of you have used Solaris? How many of you used a Solaris zone? You were actually using containers back when very early versions of containers. That's what Solaris zones were. Any of you actually used BSD? Change root jails on BSD? Those are containers. So containers have been around for a long time. But actually, I think right now, for a whole bunch of reasons that I can't get into today, I think we're in a time of container explosion. If you look at most of the major large enterprises, they are moving to containers. And so be aware this is good stuff. And if you want to keep on the edge of what's going on, keep reading and learning about containers. OK, editorial done. Containers, though, by themselves are not enough. When you actually want to run it, so it's fine for dev, but when you actually want to run it, you need to think about things like orchestration, scheduling, and isolation of those containers that are running, right? And so the project that we're using underneath of OpenShift, which is my project, we're using Kubernetes out of a small company called Google, right? And so the history on Kubernetes, it's an open source project. It comes out of Borg and Omega, which are actually proprietary and used inside of Google at this time. How many of you have a Gmail account? Or who doesn't have a Gmail account? Right, exactly. And if you did raise your hand, I would have said liar. So Borg and all Gmail is running containers. Everything Google runs inside of their data centers is running on top of containers. And they launch about 7,000 containers a second inside of Google. So when they did this, they said, oh, you know what? Our next iteration, we want to open source it, because there's a lot of benefits besides what we can do ourselves from open sourcing it. So we've been working really closely with them on Kubernetes. And then we've put stuff on top for developer experience, managing applications, and sysadmin experience. And I'm not going to get into too much propaganda. That's us. Great. So this is a cluster, right? So this is a Kubernetes or OpenShift cluster. They look exactly the same. I'm not going to don't try to read every little bit, especially since you can't, because there's horrible contrast on some of the pieces. But the basic idea is you have a bunch of nodes, right? And that's actually where your containers are going to run. Your containers are actually out here running on a whole set of nodes. So you're going to have a ton of nodes in your cluster. And then you're probably going to have a couple masters. And the masters do things like API authentication and API to the whole thing. The scheduler lives here. So the scheduler says things like, oh, you just asked for another container of PostGIS. I'm going to schedule where to put it. And it has a whole bunch of rules built in that can do that. I'm not going to talk about them right now because I only have 35 minutes. If you ask a question, though, I can tell you about the scheduler. Speaking of which, are there any questions yet on anything I've said? Yeah, thanks. No gift for you. All right. So the other thing that's different, and this is new to me, and I think it actually turns out to be awesome, is Kubernetes uses declarative configuration. So basically what you do is you say, this is the truth about the world. The world has 2 PostGIS pods, a Python server, a message queue, and they're configured this way, and they're exposed at this URL. You can put that in a JSON file or a YAML file, feed that to a Kubernetes cluster. That gets put into the data store. Then all of these pieces keep checking in to say, hey, what's the truth? And then they say, does the world look like the truth? No. Then I'm going to make it so. So the cluster spends a lot of time checking in to make sure that the truth matches what they've actually got spun up. So if something dies, the cluster checks back in and says, oh, we're supposed to have 3 instances of PostGIS running. We don't. I'm going to make the world look like the truth again. And so it self-heals that way. And I can demo that later if you want to see it. And then there's a bunch of other stuff. Is that good? But that's what a cluster basically looks like. 35 minutes is not enough, especially with demos. On this diagram, I'm going to go into a little bit of the objects. I'm not going to go into them now. We'll come back to them to explain them. But just one thing, yellow or gold is OpenShift, blue is Kubernetes. So we do a straight Kubernetes install. So if you just want to use OpenShift with Kubernetes, you can do that as well. The thing we're going to worry about right now is users and groups. So Kubernetes has no users and groups. It's just recent that they've added them, and it's stuff that we pushed up to them. They have a namespace. We wrap it in a project, so it's a materialized namespace. A namespace is where you put all the stuff you're going to use. Like your Python, your PostGIS, all of that will go inside of your namespace. It's your project space, hence the name project. Does that make sense? OK. That's high level. It's kind of an organizational feature. And part of the multi-tenancy is I can't see anybody else's project unless I have authorization to see them, and vice versa. Namespaces are wide open. OK, memorize it. Just kidding. OK, so the thing that you're going to have to worry about first is just a pod. OK, and then we'll come back to the diagram. In Docker land, you have just a container. In Kubernetes, the base unit is a pod, which is one or more containers. Do you want to know how much turtles are in this system? It's turtles all the way down. Technically, it's a container with one or more containers running inside of it. Everything in Kubernetes land is containers. So a pod is one or more containers running together, and they share a loopback address, so like localhost, and they also share disk space. So individual Docker containers actually can't talk to the same disk space. What happens with a pod is the pod mounts the disk so that both of the containers inside of it can actually use it. Does that make sense? OK. I want to tell you one anti-pattern right away, because this is what most people think. People think, oh, they're on the same loopback address. They can see the same file space. I'll put Postgres, and I'll put my web server in the same pod. No. That is an anti-pattern unless no. It's just an anti-pattern, straight up. Because what happens is if you start getting a lot of load on your app server and not much load on your database, you want to be able to spin up more app servers without touching your database server. Right? Yes? So for an example of, and I'll show it later, in PostGIS, the people at Crunchy have written an agent that actually monitors the PostGIS database. If that agent makes no sense to live by itself without a PostGIS pod, a container, sorry. So it lives and dies with that, and they live together because it needs access to seeing like all sorts of other stuff it needs access to. So things like that, things that have to live and die together, that's why. Make sense? OK, how are we doing on time? I say I have 22 minutes. Is that what you say too? He's reading his email. Do we have 22 minutes? About? OK, good. So, yeah. So enough talk. Time for demo. All right. I forgot to check something, though, before we started. And that is definitely not big enough. So the demo, you can download the VM that I have for this, openshift.org/VM. Yeah, VM. It's a Vagrant box. How many of you have used Vagrant? A bunch of you. Vagrant is a way to script a VM. So basically, if you read the instructions, you just basically say Vagrant init, the name of the box, Vagrant up, and it spins everything up. OK, so this is a way for you to play it. It's that entire cluster in one VM. Right? It's no different. The API, everything else is the same. It's just it's not scalable, not production, all that other stuff. And it's what we use in the workshop. OK, so that's what I spun up over here. The first thing I'm going to do, and those of you in the back can totally read that already. How's that? Is that better? OK, good. So the first thing I'm going to do is, what do we need to make to put everything into? What was it called? It began with a P. No, wrong slide, but good guess. Who said? Is that you? Hat or a USB charger? OK. So we're going to make a project. And we'll call this project, who wants to give me a name for my project? Short name. Ah, that's a good name. Exactly. OC new project. Short. So this is the command I use to make a project. It's done. OC is our command line tool. New app, I like to call, oh no, that was new project. So I just said make a new project. I'll show you new app in a second. Here's some instructions about what you can do. We've got a project now. The first thing I'm going to spin up is Apache. Just straight up Apache, just to show you how easy it is to run a Docker image. How many of you have installed and ran Apache before? How much, OK, you don't get to talk with the baseball cap in the back. How much fun was it installing and running Apache? Loads? Yeah, not, right? Like in your life, because usually you do like an apt-get or a yum install, and then you've got to do all the configuration, right? So here, I'm going to do OC new app HTTPD. So remember, so for those who were in Sophia's session, you remember she said there's Docker Hub, which is a collection of Docker images. That is the default Apache HTTPD Docker image in Docker Hub. If usually for most images they have a namespace and then the name of the image, but because this is the Apache HTTP Docker image, I just can say HTTPD. Clear? Yeah. What? OC is OpenShift command line tools. Isn't that obvious? Just kidding. So there. So, and this, did I hit enter? There we go. So this is the part where I'm going to start showing you more of the diagram. Oh no, I'm not. I'm going to show you it running first. Because it should be up by now. There it is running. So that's how fast it takes. See that pod, that one blue pod, and it's running? That's how fast, it was actually faster than that. That's how fast it is to spin up Apache now. Do you understand why it's that fast? It's not only is it pre-configured, it's compiled. I'm not booting an OS. There is no OS to boot. This is a binary, and I'm spinning up a binary. Do you want to see how fast it is again? Sure? No? No gifts for you. Ready? So I'm going to actually now scale it up using OpenShift. Come on. Oh, I should have listened to your advice. There, it's done. Right? So that's up and running now. So now I have 2 instances of it. And you say, well, great, what can I do with that now? Nothing, really. It's a service that's running. And the question you're going to want to, the next thing you're going to want to do is expose this to the outside world. Right? Don't we want to do that with web servers usually? Right? By default, we don't expose anything to the outside world. Okay, nothing has a route. So I'm going to say create a route. And then I say create. And now I've got a URL. Oh, wait. This worked in shoot. I think zip.io is causing a problem. Does anybody know what zip.io is? I mean, sometimes if I go to the site, yeah. Are you guys all? So what zip.io is? I'm going to actually start booting up my, I don't know if this will work, but I'm going to start booting up my MiFi. I should have run it from the beginning. Zip.io is a DNS service that actually allows you to route to private IPs. So if you notice that IP address for the service, 10.2. It's got 10.2.2.2.2.2.2.2.zip.io. What that says is when I make that request, it goes out to zip.io and it comes back and it says route that request actually to 10.2.2 on the local box. And it's a great service, except when a network blocks it. So if you try the VM at home, and especially if you try it on your corporate network, that's probably what's going on. So let me just give it a quick try. I have 15 minutes. So let's, actually, you know what? Let me start up the next thing while we're waiting for that. Or I'm going to, actually, hold on. Just hold on. Stop pushing me so hard. Come on, see the network port. Okay, let's go back to here. There's a couple things that got created when I made that Apache image. We made a deployment config and a service. And we're not going to talk about image streams today. They're cool, but I don't have enough time. So a deployment config is in a service. So what do those 2 things do? Oh, and I use the new app command. Let me start there first. So what does new app do? I fight with my devs every single day about the name of this command. Because we don't have applications in OpenShift. You have applications and they all look different. We have projects, and then you choose different things to expose inside of your project that makes up your application, right? That's an editorial, though. What happens here is new app is basically, I want to call it like OC Translate or OC Magic. Because what it does is you say, here, I'm going to give you some things which are not native Kubernetes or OpenShift objects. Go ahead and take your best guess about how to make these into things I want to run. And then it goes off and does it. Right? So OC new app here, it said, oh, you got this Docker image, you're definitely going to want a deployment config, and you're definitely going to want a service to run those. So I'll make those for you by default with the default settings. So what do those pieces do? Can you see that in the back, or do I need to put it back into presentation? Kinda. I saw a wiggle, so is that better? Okay. So remember our pods. Service is basically nothing more than a proxy and a load balancer. Right? 15 minutes. Good. So service is nothing more than a proxy and a load balancer. In this world, you don't want the database pod and the app server pod or all the other pieces talking directly to each other. Right? Because in this world, if I spin up 3 more databases, read proxies, how am I going to actually tell the app server which ones to read from? How am I going to tell that there are new ones? Am I going to go in and manually configure that? You can't, right? So what a service is a load balancer and a proxy. And so basically everything that gets stood up, every pod that gets stood up, gets a service in front of it. And then when different parts of the apps are talking to each other, they talk through a service. Does that make sense? So that's what a service is. It insulates the different pieces of the application from having to hard code stuff in. Got it? Okay. Deployment config wraps a replication controller. A replication controller says, remember I spun up to 2 pods? Basically what I told the replication controller is change your number of replicas to 2. And the replication controller says, okay, I'm going to make sure there's always 2 pods up and running. We think people want more than that. And so the deployment config lets you do all sorts of fun things, one of which is things like when there is a new Docker image for this image, go ahead and deploy it and use a rolling deploy. So bring one down, bring one up, bring one down, bring one up, bring one down, bring one up, bring one down, wait 30 minutes, bring one down, bring one up, wait 30 minutes, bring another one down, bring another one up, wait another 30 minutes, bring one down, bring one up. So you can basically do, with no configuration, a canary deployment. Automatically. Do you guys know what canary deployments are? Some of you? Look it up. I don't have time to talk about it. You should have known before you came to class. Okay. So is everybody good now on a kind of? Just kind of let it wash over you and then, yeah. I don't know what else to say about it. So let's see if we can actually now get to the other Wi-Fi. There. It actually will probably kill my entire VM to switch the network out underneath, but who cares? All right, so let's try again. You done? Oh, I don't need to press escape there, do I? There. So it worked. That was our Apache one. You want to see it again? There was no applause, so obviously you guys didn't understand what just happened. So let me do it again. Ready? There. So that's actually how easy it is to route to the pod now. So now I'm going to actually spin up. So does everybody get the basic use case scenario? We're going to step up one level, and I'm going to spin up something that I have wished for my entire life. And the people at Crunchy have made this possible, and now I live in awe of them. So I'm going to copy the command because no one sees me like putting in typos. And so what I just spun up here, I did an OC new app on a JSON file. Remember I said you can make the truth of the world to be a JSON or YAML file? I just did that. It has templates with usernames and passwords and all sorts of other stuff in it, and that get auto-generated. And what I've just spun up inside of there is master-slave replication for PostGIS with one command. Right? So there's the slave. It's already up and running as one. It's going to take a little while for the master to get written to our internal registry, and that'll spin up probably in about a minute, and we'll have master-slave replication going right out of the box. And I didn't have to do anything to make that happen. Are all of you developers? Is anyone not a developer? No? A couple people? You're already in my class, but you're not. But have you ever tried to do master-slave replication as a developer? You did? And again, quiet. How much fun was it? It's no fun. You even say it's no fun. Oh, so that means it's really no fun. And I've always wanted to do something like this. And then I just started looking at the doc, and I was like, I'm going to be yak shaving for a week, and I'm still not going to have anything that's working or correct. So once that's up, we'll start doing some of the other commands. It should come up in a minute. I think this has been new to me. This didn't happen in our class, did it? It came up right away. So something changed overnight. Let's see, what else can we do? What was the next command? Everybody see it? Look ahead. Oh, we're going to load some data, but I have to wait for the master to come up. While we're waiting for that, then I'll start the next part of this. Oh, I keep flipping between the wrong. It always confuses me when I have too many tabs up. I'll show you where it's stuck. Actually, we can look at the deployment log. So basically what it's doing is we're waiting right down here for it to become ready. In Kubernetes, you can do things with pods. You can have a liveness check and a ready check. Right? So you can write these in, and inside your pod or container, you can say, 10 minutes, that's fine. the liveness check says, is this pod even up? Right? And so Kubernetes will keep checking. And if it returns I'm not up, it'll kill the pod and try again. It'll say, obviously that pod is dead. I'm going to start a new one. The other one to do is a readiness check. So this is usually used with app servers or something, where if you spin up a new one, you don't want to plug it into the load balancer and start serving stuff to it right away, right? Because it may actually not be up and ready to serve content. You don't want someone to get a 500-page error. So the liveness check, the readiness check, once that passes, then it actually goes through and starts routing stuff. This kills me. I don't understand why this happened. I'm going to blame it on the network because I had to switch, although I don't think it actually is. All right. I'm going to have to start the next part because I can't keep waiting for that. So I can't load the data. I can show you something I'm going to need in a bit. So this slave pod is already up. If I go to the slave, that's the pod, right? And so I'm inside the pod now, and I can do things like the metrics aren't available because we're using self-signed certs. And I'm going to say, that's OK, go ahead. Great. Now go back to the metrics. You only have to do that once. There's the metrics on that running pod. There's memory consumption. And there's CPU. But the other really nice thing I can do is terminal. I'm now actually SSH'd into that PostgreSQL Docker container that's running. So I can actually do things like PSQL, user. I can't make the font on this bigger, so sorry. PSQL, no. It must not be up. Oh, it's not up yet because it wants the master to be up. Come on, master. All right, I may have to not be able to show my entire demo. Isn't that fun? All right, let's keep going. The other thing I'm going to show, and this I was going to show, and maybe this will work, is I'm going to do OC new app again, but this time I'm going to load a source code repository and a Docker builder image. And then I'm going to use that to create source code. And the root password will be wrong. We'll just have to go in and change it. So if I go back here, oh. There. So now what I've done inside of my same project is there are now two new things. I'm actually now building source code. And the build failed. Okay. I should have started with the network to start with. Yeah, it can't resolve GitHub. Because I've got this Git repo. Oh, it is actually not there. Was it a copy and paste error? Let's try again. Oh, no. That's not going to work. It already exists. It was a fun talk. It's not fun anymore. Let's do this then. Let's go to the build config. So there's the build configuration. And let's go to actions. And let's edit it. And let's get the real Git repo, since it didn't like that repo. Let's copy it. The actual application I'm trying to use is, and I can do all sorts of things. Why didn't it? No, it's the same thing. I think I broke the networking on the VM. Yeah, I can do that. Thank you for giving. I'll give you 2 pieces of swag because you rescued me from the mire of my failed demo. So what you would have seen there is a build happen, and then I would have explained why we need a build, and then you would have seen that app talking to the master-slave replication, writing to the master database, and then reading from the slaves.
I already got a USB thing, yes.
So you only get a hat now?
Why is red hat hats black?
Because to get a Red Hat that's red, you have to work at Red Hat. You want the USB? You get one because you sat next to the guy who asked the question? Okay. So OpenShift, lesson to everyone, choose who you sit next to. OpenShift origin, that's our upstream for OpenShift, right? So that's where all the source code happens. It's up in GitHub, openshift.github.com/origin. That's all the bits. And that actually merges in Kubernetes. It merges in Docker. It uses Open vSwitch. It uses all sorts of all these upstream projects and puts them together into origin. OpenShift Enterprise is like RHEL. Does everybody know what I mean when I say RHEL? Red Hat Enterprise Linux, right? So once every quarter or so, we package all this up and we ship it as bits that you can install anywhere you want to ship them. OpenShift Online is where we host this as a service ourselves. The current version of OpenShift Online is not running the version based on Docker. So you can go play with it. You can get a free account. You can start building apps. And I think it's pretty awesome because it's a platform as a service. And if you're a developer and you haven't played with a platform as a service, life is sad. But that will be moving sometime probably next year. There's a lot. We have over 2 million applications there, and thousands and thousands. There's actually an open beta of this probably coming sometime this summer. I'm saying next year to temper expectations. You'll be very upset with me if I say it's coming at the end of this summer or this fall, and then it's sometime next year, and you're like, that liar. So I don't want to get you in that situation.
The versions of the cartridges are not up to snuff.
Or not that. I agree. As the evangelist of this platform, I live that pain almost every day. Anyway, 5 minutes. So does that explain the different versions?
No, it does. When the conversion does happen, our cartridges can be auto-converted in the dock.
No. Well, so that's one of the things that should be, because one of the things that should stay basically the same for you is your source code should not really have to change that much. Exactly. Because one of the things is, if I show you the non-building source code, right? If I show that to you here, so let me load up app.py. Or no, that's the repo for it. How many of you are Python developers? Okay, does that look like a standard Python project? Is there anything that looks odd to you about a very simple Python project there? It's not really a hard question. What? There's no what? There's no init. Right. But there's, inside of here, I've got if name equals main, right? So we're already setting up the web server. I'm already running. It's just, this is a project if you assume you already have a running web server, right? You're not going to init a web server. But it's just a requirements.txt. There's nothing particular about this. So what we do with source to image, which is our builder that we use, is it's called a builder image. Because what are Docker containers? Can you change them and have them run on the fly? No, they're immutable. Thank you. So what that means is you can't just, not like a VM where you can just dump your source code in and have it just work, right? So there's two different ways to do this. You can either do a Docker build, which is where you recompile a new Docker file and tell it to load the source code over. We have a process called source to image. It's an alternative. The idea with this is you give a source code and you give what's called a Docker builder, which knows how to build the files, right? So for Java developers, are any of you Java developers? 1, 2, 3, 4. Like they're all ashamed and it goes up slowly. And then once one shows, the other's like, oh, maybe it is okay to be a Java developer. The idea is you just give it a pom.xml and it knows how to build it. And what it does is it creates a new Docker image that is then runnable. Right? So that's how that process works. So that's, yes, when we move over to v3, your source code will still work. Some of how you wire things together will change, but the benefit also will be you can basically run any version of anything that you want to run. One of the reasons we made the switch early on, despite all the pain, because we had v2 running, it was great, all that stuff, but we realized pretty early on that containers, and there was a huge ecosystem forming around Docker. Like we would go to people and say, could you build us a custom cartridge? And they'd be like, for just your platform? No, right? And so now you just say, hey, do you have a Docker image? Yes. Does it run as root? No. Great, you can run it, right? So now we have all sorts of people who we can now use all sorts of things that we couldn't before, right? And people are building it for Kubernetes, and if you build it for Kubernetes, you build it for us, and so So it should be an easier migration path. I don't think anything actually came up. Now let's actually see. God, I know I only have 2 minutes, but I probably only have none. But I actually want to see if at least the master came up so I can show you. No, it failed. I'm sure this is because it can't see Docker Hub and GitHub now. So sorry for the networking problems. I don't know. Maybe I should do a webinar and show it working or something like that. For those of you who are in the workshop, this all worked in the workshop. You can ask them how awesome and cool it was. And I didn't give them each $50 each to make them say that. The idea that I would have said at the end of this is, look how cool and easy it is, which it really is when you don't have to try to switch networks in the middle of your presentation. So the final summation is, we're in a time of container explosion. You need more than just containers. Look to Kubernetes and OpenShift. There's other projects that do orchestration and scheduling, though. What are some of the others? Does anybody know them that weren't in my workshop because you already got to hear them? So we do orchestration, scheduling, isolation, all that other stuff. There's at least 2 other major projects that do this. Sophia, what's yours? Docker Swarm. I am also the evangelist for Docker. Now I'm on DevRel for Docker. Docker Swarm does this kind of stuff. And then the other big one is Mesosphere. I don't know if any of you have heard of it, but Mesosphere is the other one. So I like mine. Surprise, surprise. But I also recommend you look at Mesosphere and you look at Docker Swarm. Right? There are also container orchestration. There's a very long runway in this ecosystem. That's the whole explosion, right? This is just the beginning. So remember when VMs were 2 years old? How much fun were they? Or 3 years old? How much fun were 3-year-old VMs? Would you use them? Did you try to use them? I would never use them. Like I saw Microsoft ship the VM, and VMware had that stuff, and I was like, no, I want a physical machine. You can't take physical machines away from me. But now everybody uses VMs. So I think we've actually come farther than VMs have in 2 years or 3 years, right, with this ecosystem. But it's still a lot. And then upstream first. So all the stuff that we're doing is upstream. There's the slides again. Actually, oh, you can't. I was going to say, you know what, I could change these. Actually, I'll do that. Did everybody get the URL for the slides? Yeah? Okay, so what I'll do is I'll tell you where this repo is. And then I'll tell you, oh, this repo is probably, the other repo is probably not around for the database. This containers. I think Jeff closed that back up. The people at the workshop got to see beta versions. But I'll show you where this, oh, you actually can see exactly where it is in the slide. You can run this if you want. You can download the VM and those commands will work. And as a matter of fact, if your networking is working, these URLs will work too, right on your machine as well. So the slides again were bit.ly.v3 short. Yeah. Requirements. So the question was in the Python app, how do we define dependencies? Right? So there's 2 ways for the Docker image. There's 2 ways you can handle this, right? You can either bake them all into the Docker image, which is not very friendly, because they change, because then it's baked into the image. What we do is we actually, because of the build, that's what the builder part is. So what we do, if I go back to this, you'll see there's also a requirements.txt, right? And so what happens is during that build stage, we pip install, the Python builder knows to look for requirements.txt, pip install those as part of the build process, and then those, just the ones it needs, ends up in your Docker image. Does that make sense? Same thing with a Maven build or a Ruby build, any of those things. PHP build, even if you do a PHP build. Yeah. So where do you put the data so it's persistent? That is a great question. If you just use Docker containers by themselves, it'll let you mount the local file system. In Kubernetes, there's a whole bunch of different ways to mount data. So you can still do something called like a local dir, which is load data on the node. So this is like in EC2 when you actually use the data locally. If that pod goes away, it goes away, right? So that's not really a very good idea. The other idea is we have persistent storage, and that was where the volume claims, persistent volumes come in this diagram. So a persistent volume is defined by the administrator of the cluster. And what they do is they say this persistent volume is backed by an iSCSI device. This persistent volume is backed by a Ceph device. This persistent volume is backed by an NFS mount. And then as a developer or as a pod builder, you make a claim to that space, and it appears as part of the file system in your pod. And then you can write to it, and it'll be out there. So there's two different. Wait, hold on one sec. There's two different ways you can do it. So like back with our Apache one, we would probably want all of our Apache pods making the claim to the exact same claims to the exact same persistent volume, right? Because Apache is just static files, so we just want it to serve up the static files across all the pods that scale up. Our database replica, we do not want that because that would be a bad thing, right? So there you can say make a new claim and grab some new space. Yeah, you had a follow-up? In what way? What do you mean? Yeah.
And I've got the Postgres master. That needs to map to something persistent, so I keep it.
Yes, they all do.
But I think it slaves down.
No, they don't. Sorry. The question was, do they map to persistent space? And I may have misspoke. They all make claims to persistent space. And they're separate as opposed to the Apache one where they can all make claims to the same space. Does that make sense? Yeah. Actually, in your use case, you may actually also say, I don't actually even want to use, for my slaves, I'm not going to use a persistent storage. I'm just going to use the disk storage because if one goes away, who cares? Right? And I want it to be really fast because I want it writing to the local disk rather than out over whatever. You can make that decision for yourself. So we're over time, but I'll take other questions if people have them. I know I went really fast. Does everybody understand the whole why you would do this in the first place, though? No? Yes? Okay. Yeah. Okay, so I'll go into more detail now. I said I wasn't really going to before. This is the builder image. It knows how to run source to image, right? So what is in that Docker image, a builder Docker image, is just 4 different scripts. One that's a build script, one that's a help script, one that's a run script, and I forget what the other one is. The run script is basically you just take whatever was in Docker run statement before and put it in the run bash script. The build script is the one where you say something like pip install everything in the requirements.txt. When the build runs, it copies the source code and puts it into a tempter in the Docker image, and then builds it and puts it where it needs to end up. Does that make sense? And then snapshots that image out after it's all set and done. Then what happens is, after that build is done, it actually pushes it to the integrated Docker registry. We have a Docker registry actually inside the cluster. And then the deployment config is actually saying, I need to run that built image. So when there's a new version of that, go ahead and deploy it. So if you fire off a second build, it does a build, pushes it to the registry gets updated, the deployment config says, oh, there's a new one, I'm going to go ahead and deploy it. Does that make sense? Okay. We also have a feature now where you can, it's not even that new, you can rsync into the pod, into the container. So while you're doing rapid local development, most of you probably don't want to go through a whole build every time you're doing Python stuff. You just want to drop a Python file in or drop a war file in. So you can actually rsync right into the pod, have it quickly reload the stuff that you're working on, and then once you're done, do a git commit and push that all in as well. Right? It doesn't have to always go through the build cycle. Yeah. Behind you. Wait, behind you. Into the build scripts, there's usually no passwords in the build scripts. Sometimes there's build secrets if you need to talk to like some build server or something. There's a couple different ways you can do it. You can do it with environment variables. That's the least secure way of doing it. There's also, there's a new thing that just came out called config maps, which is an object you can define, and it's a mapping of usernames and passwords and stuff like that. And there's also a secrets file. So in the same way that we could mount persistent volumes before, you can mount a secret and a secrets file, and it appears as a persistent volume claim. Right? So you don't actually get to see it, let's say, but your administrator can say in your pod description or your deployment config, mount that secrets file. Does that work? And I didn't show this, but in that JSON template, it auto-generated usernames and passwords, a random sequence. It wasn't hard-coded in there. And you had a question. Yeah. In Kubernetes, there is a scheduler. I don't know what it's called, but there is a scheduler in there. And I know that's one of the stronger parts of Mesosphere, or Mesos, is the scheduler. There was talk at one point about taking Kronos and having that ability to put that in Kubernetes. I don't know what's happening with that, though. Yeah?
What does this look like when you actually want to like put it in production on Amazon? Would you be using it the VM, or is the VM that you got there?
The VM is completely for, like, I've turned off all security restrictions in the VM. The VM is for playing and for deving, right? Because I don't want to deal with the security. It's like everybody turns off, well, all the Linux users, they used to be really restrictive SC Linux on your desktop, the first thing everybody would do is just turn it off, right? Because you don't need it. In here, I've turned it all off in the VM, and there's also no redundancy, right? It's all in one VM. In Amazon, when you run this, you would have, for production, you'd probably have 2 masters and a bunch of nodes, right? You can run it in Amazon, you can run it in GCE, and you can run it in Azure as well, if you wanted. Or on OpenStack in your own private cloud. So the other thing back in this cluster, we don't care whether this is a physical machine, a VM, whatever, as long as you give us the OS, we'll run on top of it. So you don't actually, doesn't really matter to us. Does that make sense? Okay. There was one other, well, the guy left, but